Hi guys, I'm Shohit Upadhyay. In this video, I will be sharing with you the winning approach of Ericsson Machine Learning Challenge. It was a two-round hackathon. First round was the online round. We need to solve two problems. And in second round, the top participants from the first round were invited to present their approaches in front of jury. I won this competition by securing second rank. So the first problem statement was we need to predict the material type. Assume that you are a member of marketing agency and you are given a dataset having the title, subjects, and other features based on which you have to predict the material type. So following are the material types: book, sound disk, video cassette, sound cassette, music, mixed, and CR. The training data contains around 31,653 rows and 12 features, and test data contains around 21,102 rows and 11 features. This is the brief description about each feature given for this problem statement. We have features like title, creator, subject, publisher, and publication year. We also have information about usage class, checkout year, checkout months, and the number of checkout happened during a month. So the material type is the target column for us. This is what we need to predict. Now we have the overall understanding of problem statement. Let's analyze the solution. We will be exploring more about each features by drawing plots. This will help us to make decisions like what features to drop, what feature engineering we should do before feeding it to the model. This is the frequency distribution of target material type. This denotes the dataset is imbalanced. We can see here book is the majority class and music and CR is the minority classes. We have around 21,000 data points that falls into the book class, and we have around 165 data points for music and 94 data points for CR class. This plot represents the distribution of usage class, checkout type, checkout year, and checkout month features. One decision we can make after seeing this plot is we can safely drop these features. As you can see here, these features has no variance, means they all contain same value for every data point. If we feed this feature to the machine learning model, ML model is not going to learn anything. This plot represents the relationship of checkout and material type. We can clearly see that if a data point has checkout count 1, it is highly likely that it belongs to the book class. Let's zoom to the plot and see if we can have any other pattern. Okay, so similarly, if a data point has checkout count 13, so there is a slightly high chances of belonging to the video disk class. Okay, let's move to next feature. This is the relationship plot of creator and material type. It denotes that majority of authors belongs to a specific class. For example, all the data points that has an author Gibbons Gale belongs to book class, and author like Who musical group belongs to sound disk class. There are few exceptions also. Author like John Sebastian belongs to sound disk as well as music class. Moving to next feature. This plot also tells about the same kind of relationship. Most of the publishers belongs to the specific material type, but there are a few exceptions also. Publisher like Martin's Press has published book as well as CRs. This is the relationship plot of subject and material type. We can clearly see that same subject has been used for various data points. For example, around 175 data points has subject rock music, and subject feature films has been used 182 times for video case and 46 times for video text class. Till here we have analyzed all categorical features. Let's explore more on text feature title. This is the word cloud of all the titles that belongs to the book material type. The most frequent word like book, novel, guide, story, stories that is represented by bigger font are much more related with the book material type. Same thing again. This is the word cloud plot of sound disk, and the most frequent word like sound recording, song, music are related with sound disk material type. Let's move to handling of missing values. We can see here creator feature has around 73% missing values. Publisher and publication year has around 69% of missing values. The percentage of missing values is very high here. So I have decided not to impute with most frequent values because this will make the model bias toward those values. So I am imputing publisher with no publisher, creator with no creator, and subjects with no subject. We have explored enough about various features and we have taken care of missing values as well. Now it's time to create a feature engineering pipeline. What we are doing here is first we are concatenating title, subject, creator, and publisher to create a new text feature called as info. We are feeding the info feature into three parallel pipelines. First pipeline will extract bag of word features. Second and third pipeline will extract text length and word count from the raw info feature. Before extracting the bag of words, we will be doing the text preprocessing like text normalization, cleaning of extra spaces, punctuation removal, and then we feed these clone tokens to TF-IDEA vectorizer. Along with these features, we are also going to use checkout, subject, creator, publisher features as well after applying the label encoding. Let's see the same thing in the code, how we are doing it. Here we are concatenating all the features as described before. We are also doing the label encoding here. This is the tokenizing function for us. We have also written the text length extractor and the word count extractor. We have the message extractor also. So this will extract checkout, creator, publisher, and subject from the given input. So a pipeline function looks like this. So as you can see here, we have four different pipelines. So first pipeline will create the bag of word feature, and the second pipeline will extract the categorical features. Third pipeline will create the text length feature, and the fourth pipeline will create the word count extractor. We have called the pipeline fit function here, and here we have extracted the features drawn from the pipeline. Let's talk about the modeling part. We are using the AutoFold prediction technique to create an ensemble model of five different XGBoost classifiers. So the input for this is generated features from the feature engineering pipeline. We will be splitting those features into five folds by using stratified K-fold technique. We will be training five different XGBoost classifiers by using four folds for training and keeping out one fold for prediction. Each classifier also predicts on the test data, and at last, we will be combining all the results of the classifier by averaging them. Let's see the same thing in the code. We are setting up here the parameters for the XGBoost. We are also using a stratified K-fold by giving five number of splits. In this section, we will be training five different XGBoost classifiers. We are also doing the prediction on the test data. We can see the validation score on a different data set and the averaged validation score by combining all the results. Here we are preparing the output and we are generating our submission file here. So that was all about the first problem. Now we'll move into the second problem. For this problem, data represents the job reviews and our task is to predict the overall rating of the reviews. Training data contains around 30,000 rows and 17 features, and test data contains around 20,000 rows and 16 features. This data contains different features like place, location, date, status, job title, summary. We also got positive and negative feedback. We also have internal scoring features from 1 to 6, and our task is to predict the overall rating from 1 to 5. So the approach to solve this problem is almost similar compared to the previous problem. We have drawn the same kind of plots like the target distribution plot, the frequency distribution of place versus overall rating, frequency distribution of location versus overall rating. We have also drawn the frequency distribution of scoring functions from 1 to 6. We have also analyzed the most frequent words occurs in the text data for different ratings. Feature engineering pipeline to solve this problem looks like this. First, we are concatenating summary, positives, negatives, and advice to management features to create a new text feature called as info. We are feeding the info feature into text preprocessing. We are doing text normalization, cleaning of extra spaces, punctuation removal, and then we feed these clean tokens to TF-IDF. Along with this, we are also using place, location, job title, status, and other score features. We are also doing label encoding for all the categorical features. And then all the generated features we are passing it to XGBoost classifier. Thank you guys. That's all for this video. Please give a thumbs up if you have liked it and do not forget to subscribe the channel. Until then, bye bye.